We'll proceed in innovative approach in calculus and we will see Taylor polynomial expansion. We have our own invention in the Taylor polynomial expansion. What is Taylor polynomial expansion? That we will see first and then we will see what is our invention out there. So that is kind of idea that we will take forward. So Taylor polynomial approximation. This is the perfect word for the polynomial approximation. What is a polynomial equation? Polynomial equation is nothing but in a form of x and x to the power n. Like if I have a function that is a polynomial function, then it is typically a constant plus x to the power 1 or a constant into x to the power 0 plus a constant into x to the power 1 plus constant into x to the power 2 plus constant x to the power n. This is typically called polynomial function. Monomial function when it is up to x to the power 1. Binomial function, okay, binomial when it is up to x to the power 2. Trinomial or whatever. So can I represent any algebraic equation in the form of x to the power n? Sin x, sin x is a trigonometric function. Sin x is a trigonometric function. Can I represent sin x in terms of x plus x square plus x to the power 3? Amazing, right? Sin x is height by hypotenuse. If I draw a triangle and it has an angle, then height by hypotenuse is the sin x. If angle is x in radian, okay, can I represent sin x in terms of x plus x square plus x to the power 3 plus as if sin x is not a trigonometric function, sin x is a polynomial function. That is the concept. Okay, anyway, whatever we are talking, it is easy way to prove a Taylor approximation. So any polynomial, any function, any algebraic function, either it is log x, e to the power x exponential, sin x, tan x, whatever it is, or combination of everything. If I have a black box, if I if I have a black box, this is a black box. Doesn't look like black though, but this is a black box. This is a black box. If this is a black box, it is bunch of algebraic equation, bunch of algebra. Sin x, log x, ex into log x plus sin x into tan x plus sin x into e to the power x bunch inside it. Now, the question arising is, can I represent this bunch? Can I represent this bunch as series of polynomial form? Whatever it is, black box, I don't care. Can I represent this box? Can I represent this box as series of polynomial equation? That is the concept. What is series of polynomial equation? Okay, what is inside your box? I will not reveal. What is inside my box? I would not reveal. What is that? That is function over x. That is function over x. What is your function over x? I'm not going to reveal you. Okay, now can you tell me what is inside your box? Okay, secretly I'm telling you it is sin x plus e to the power x log x plus this. Can you calculate integration of this? Amazing, impossible. Okay, so innovative approach in calculus. How I can proceed? Differentiation is all right. Means especially if I see differentiation, that is the chain rule in the differentiation, it keeps breaking step by step and making it simple, and differentiation happens. chain rule in differentiation, it happens. But if we see analogous to the chain rule in integration, then it transforms into integration by part. Step by step, it becoming even complex because integration is multiplication, right? It will make things bigger. Differentiation is division. It makes things smaller. So doing calculating differentiation is all right. Calculating integration is always very difficult. Always. If it is a simple form, then it is all right. Otherwise, it is head hitting. So there are mainly two ways in the integration. One is method of substitution. There we have talked about kind of Jacobian transforming into other coordinate system and working with the method of substitution. There is another way in integral calculus is integration by part, that is equivalent to chain rule in differentiation, integration chain rule here also. But if you go more, it is head breaking. Can it be simple? I don't know this much. Your black box, little bit I am getting, little bit smell of it, and it is way away from impossible also. I cannot calculate integral calculus of the your black box. Can you make your equation simpler? What do you want by simpler? Simpler means x to the power 1, x plus x to the power 2 plus x to the power 3, like that. Then very quickly I can calculate the integration. But it not be that perfect because it is approximation. I don't mind. Better than not able to calculate it at all. Okay, so there are other way to calculate integration also. One is also called numerical way. Numerical way means you draw the function and then make n number of part, and every part you take one line and get the area of it and sum it. Okay, Riemann summation or something like that it is called. Through that also someone calculate the integration. No, this is all right. If I am getting simpler form of any complex algebraic equation as set of polynomial equation, this is all right. After all, doing nothing or going by numerical way, this is better way. If I have a black box is set of algebraic equation, then question arises is how I can get polynomial approximation of it. That is under question mark. Now, let's see that this black box is a polynomial equation. Black box is a polynomial equation. Black box is a polynomial equation. Can I make a copy of the polynomial equation? Just copy it by pen and paper. What is there? No. Something else we need. Okay? Copy, sometimes it is very difficult. It is just not that you copy any data structure. Deep copy. We want deep copy, bit by bit, not the surface layer. Full copy. What do you want? Okay, I'll tell you what I want. What is your polynomial equation? My polynomial equation is fx, function over x, y. Fx equal to a0 into x to the power 0 plus a1 x to the power 1 plus a2 x to the power 2 plus a3 x to the power 3 plus an x to the power n. Can you duplicate this? Okay. Now tell me the value of this, the value of your function, when x equal to 0. Okay. Typically, how we draw a line equation. I have any equation. Consider I have any equation y equal to mx. This is the typical form of a line that passes through origin. Y equal to mx, where m is some constant, or some people say it is dy by dx, whatever. So y equal to mx. Now this is y-axis, this is x-axis, and y equal to mx is this line. Okay, this line I shift little bit up. Now Earlier it was passing through origin, now it is passing through 0, comma 2. What is the equation of the line? Then it is y minus y0 equal to mx minus x0. This is the actual form of a line. Y minus y0 equal to m in braces x minus x0. What is x0, y0? X0, y0 are the point through which this line crosses. They are the point through which this line crosses. Okay, well, all right. Then it is crossing through 0, comma 2. Then what it would be? Y minus 2 equal to mx minus 0. Y minus 2 equal to mx. Y equal to 2 plus mx. This is the new equation. Or when x equal to 0, what is the interception on y-axis? That is y minus 0. Y minus y0. When x equal to 0, the interception on y-axis is 2, then it is y minus 2 equal to mx. I believe it's all right. Okay, now consider, now this is x-axis, this is y-axis, and line was this is x-axis, this is y-axis, and line like this, where m is the slope, y equal to mx. Now this line I little bit made an offset and it went up. If it went up, then it is intersecting y-axis, but negative side of x, it is intersecting x also. Okay, consider it is passing x at minus 2, comma 0. Passing x at minus 2, comma 0. If that is the case, if it is passing y at 0, comma 2 and x minus 2, comma 0, then the m that is dy by dx is 1. But anyway, consider it is m only, and this line is passing x-axis at minus 2, comma 0. I don't know where it is crossing the y-axis. What about now? Y minus y0 equal to mx minus x0, where x0 is where y equal to 0. Or at that moment, it is y equal to mx minus minus 2x plus 2. Y equal to mx plus m into 2. There are many ways we can represent a line. Now, if I am saying fx equal to a0 x to the power 0 plus a1 x to the power 1 plus a2 x to the power 2 plus an x to the power n, this is a polynomial equation. This is equation of a curve, non-straight line. Monomial equation means x to the power 1 means it is a straight line. X to the power 2 onwards, then it is non-straight line. X to the power n means it is in a sky, Bezier curve or curve that no one has ever seen, whatever it is. If I say fx equal to a0 x to the power 0 means fx equal to a. Fx is y, then y equal to a0. Y minus a0 equal to a1 x1 plus a2 x2 plus a3 x3 plus an xn. This talks about this polynomial line intercepting y-axis at a0. Can you see this? Amazing, mind-blowing. Why? If you see in the book, typically it would be written, what is the equation of your polynomial equation? Fx, that is the polynomial equation. Fx, y, fx equal to a0 x to the power 0 plus a1 x to the power 1 plus a2 x to the power 2 plus xn x to the power n. What it is? a0 x to the power 0 means a0. a0 I can take left side. Fx I can replace it by y. Y minus a0 equal to a1 x to the power 1 plus a2 x to the power 2 plus a3 x to the power 3 plus an x to the power n. Y minus a0. The way we talked y minus a0 means when x equal to 0, this is the intersection on the y-axis at a0. That is y minus a0. So what about this formula fx equal to a0 x to the power 0 plus a1 x to the power 1 plus a2 x to the power 2 plus an x to the power n. If that is the case, this is our proof. Probably you will not get anywhere. Okay, you will get but in different form. Okay, now what about this fx or y where x equal to 0, that is equal to a0. Okay, one thing. Now when x equal to 0, fx at x equal to 0, fx at x equal to 0 is equal to a0. Okay, can I replace now a0 saying fx at x equal to 0? Y at x equal to 0, it's a constant. Okay, let's proceed. Actually, we are trying to copy this. Let's differentiate it. Fx, dfx by dx or dy by dx. Dy by dx equal to a0 gone. a1 x to the power 1 becomes a1 plus a2 x to the power 2 becomes 2a2x 2a2x plus 3 plus a3 x to the power 3 becomes 3a3x square. Like that and it becomes an x to the power n minus 1. What about dfx by dx? dy by dx at x equal to 0. dy by dx, dfx by dx is nothing but another polynomial equation, another curve. What about this curve when x equal to 0? Then this curve is a1. a1, a0 anyway gone and other becomes 0 when x equal to 0. a1 equal to dy by dx, knowingly, unknowingly. Now can I rewrite this equation what I had written? fx equal to a0. a0 is nothing but fx at x equal to 0 or y when x equal to 0 plus a1x. a1 can I replace now? dy by dx at x equal to 0. Earlier it was a0, now it is y at x equal to 0 into x to the power 0 plus a1x. Now a1 is dy by dx or dfx by dx at x equal to 0 into x. Okay, let's do dual differentiation. Who stops us? This is our game, right? No one stops us. That's why mathematics is something your hidden friend. Who stops us now kind of playing with mathematics? No one stops us. Okay, probably your best friend. Let's try dual differentiation. So now I'm going to derive fx two times. So d2fx by dx square equal to a0 gone. It was a0 plus a1x plus a2x square plus a3x to the power 3 plus an x to the power n. No one stops us. Now a0 gone. a1x1 double differentiation gone. Now a2x to the power 2 becomes 2a2 plus double differentiation, then 3 into 2, 3 into 2a3x plus 4 into 3 a4 a to the power 2 plus an x to the power n becomes n into n minus 1 an x to the power n minus 2. What about dfx by dx square when x equal to 0? This d2fx by dx square itself, it is a polynomial curve. What about its location? What about its position on y-axis where it intercepts when x equal to 0? If that is the case, then 2a2 would remain. 2a2 plus 3 into 2 a3x all will go away at x equal to 0. 2 a2 would remain. Actually, this Taylor series, what we will talk slowly, actually I had personally invented that way, but later came to know that it is already done because it is required at many places. Taylor series is highly required. We will talk about it when it is required. But anyway, so let's proceed. What is d2fx by dx square? That is 2a2. 2a2. Then a2 equal to 1 by 2 d2fx by dx square. 1 by 2 d2y by dx square. That is a2. What is a0? Y or fx when x equal to 0. A1 is dy by dx or dfx small f braces x braces close fx dfx by dx and when x equal to 0 is a1. A2 is 1 by 2 d2 fx by dx square when x equal to 0. Can I rewrite now? A0 into x to the power 0. A0 into x to the power 0 becomes fx at x equal to 0 x to the power 0 plus dfx by dx at x equal to 0 into x plus 1 by 2 d2 fx by dx square into x square, where d2 fx by dx square is when x equal to 0. What about d3 fx by dx cube? Triple differentiation. d3 fx by dx cube. d3 fx by dx cube. What are you talking about? This is how we would proceed. d3 fx by dx cube. First term gone, second term gone, third term gone. Now we have a3 x to the power 3. This if I do triple differentiation, first differentiation it becomes 3 a3 x square. Next time it becomes 3 into 2 a3x. Next time if I differentiate it becomes 3 into 2 into 1 a3. That's it. Post that it becomes 4 into 3 into 2 a4x. At the end it becomes n into n minus 1 into n minus 2 an x to the power n minus 3. Okay, if that is the scenario, then triple differentiation. Now what about this value when x equal to 0? At that moment, all are gone, only 3 into 2 into 1 into a3 remained. a3 equal to d3 fx by dx cube into 1 by 6 or into 1 by factorial of 3. a3 a and at the subscript down bottom 3 a and right bottom 3 a3 equal to 1 by factorial of 3 into d3 fx by dx cube. This proves that a2 equal to 1 by 2. That is not true. a2 equal to 1 by factorial of 2 x to the 1 by factorial of 2 d2 fx by dx square. This proves that a1 equal to 1 by factorial of 1 dfx by dx at x equal to 0. Okay. Now we can proceed further. If that is the case, then a4 equal to 1 by factorial of 4 d4 fx by dx4 or d4y by dx to the power 4. If that is the case, then an equal to 1 by factorial of n, 1 by factorial of n x to the power x to 1 by factorial of n dn fx by dx to the power n time differentiation. Did we get something? I could reproduce fx equal to a0 x to the power 0 plus a1 a1 x to the power 1 plus a2 x to the power 2 plus a3 x to the power 3 plus a4 x to the power 4 plus an x to the power n. If this is the polynomial equation, if this is the polynomial equation given, it can be rewritten as fx at x equal to 0, x to the power 0, plus dfx by dx at x equal to 0, x, plus d2fx by dx square at x equal to 0, x to the power 2. I mean 1 by 2 d2fx by dx square at x equal to 0 into x square, plus 1 by factorial of 3 d3fx by dx square into x to the power 3 at x equal to 0 is the differentiation, plus 1 by factorial of 4 d4fx by dx square at x equal to 0, x to the power 4, plus 1 by factorial of 5 d5fx by dx to the power 5 5 into x to the power 5, plus 1 by factorial of n dn fx by dx to the power n into x to the power n. This is the exact representation of a very well behaved polynomial equation. Very nice. Oops. Okay. Okay, if that is the case, then what we achieve? If I have a polynomial equation well behaved, I can exactly copy it as another polynomial equation. Okay, very nice. You could have just written same thing. Why you copied it? Actually, what now if I say I have a polynomial equation and can you copy it? Then other guy, what information it requires from this polynomial equation to copy it? What he is asking? If this is the polynomial equation fx equal to a0 x to the power 0 plus a1 x to the power 1 plus a2 x to the power 2 plus an x to the power n. If this is the polynomial equation and someone trying to copy it, making exactly replica of this, then is he asking about a1, a2, a3, a4? Nothing he does. Actually, nothing he does. He is asking, can you tell me what is your value when x equal to 0? Okay, this is my value when x equal to 0. Thank you. What is your value? What is your dy by dx, dfx by dx at x equal to 0? He's asking for all the derivative only, that's it. The information what this person requires when he is proceeding to replicate one algebraic equation into a copy algebraic equation, polynomial equation, then he is asking for this kind of explanation is not available anywhere. Anyone can search anywhere. Please do support us. +91 is the India country code. 9483160610. This is the telephone number. 9483160610. +91 is the India country code. Now, if that is the situation, then replicating any algebraic equation, we need the order of derivatives only, different order of derivatives only. That's it. Is it like that? Okay. Now, if that is the true, now the person who is hiding the algebraic equation, now he has sinusoidal, sin x, fx equal to sin x. No, but he is saying, I have a polynomial equation, can you copy it? But underneath he knows that this guy is going to ask only derivative, right? Then bluff him. I have a polynomial equation. You want to copy, right? Okay. It is a polynomial equation. What you want? I want value when x equal to 0. 0. When x equal to 0, value is 0. Okay, thank you. What about dfx by dx when x equal to 0? Okay, now internally he is calculating dfx by dx. So actually it is sin x. So dfx by dx is cos x. When x equal to 0, it is 1. He replied 1. Now he is chaining it. So fx, the replica function fx equal to, first is value when x equal to 0, 0. Plus dy by dx at x equal to 0 into x, that is 1. So x. Now tell me the dual differentiation. Dual differentiation. Sin x differentiation cos x. Cos x differentiation minus sin x at x equal to 0 means 0. 0. Then he wrote 0. Okay. Now can you give it triple differentiation? So sin x, cos x, minus sin x, minus cos x at x equal to 0 minus 1. He replies minus 1. Now he is filling 0 plus x plus 0 plus now triple differentiation means 1 by factorial of 3. 1 by factorial of 3 dy by d3 fx by dx cube, that is minus 1. Minus 1 by 6 into x to the power 3. Okay, minus x minus 1 by 6 x to the power 3, that is factorial of 3. Okay, that is a factorial of 3. So he silently wrote x 0 plus x plus 0 minus 1 by 6 x to the power 3. Now can you give me fourth derivative? First is sin x to cos x to minus sin x to minus cos x to sin x at 0, 0. Now, okay, sin x. Now can you give me sixth derivative? That is again sin x to cos x, 1. Then plus 1 by factorial of 6 into x to the power, okay, whatever I went, I believe I forgot it. Okay, this is the way. So first he tried with the x first derivative, then it became 1. So x plus third derivative 1 minus 1 by 6 x to the power 3. Fourth derivative 0, fifth derivative 1. Then 1 by factorial of 5 x to the power 5 plus 6 would be 0, then 7, then 9, and like that. Now he is saying actually your equation, actually you are hiding the algebraic equation, what you are hiding underneath it is x minus 1 by 6 x to the power 3 minus 1 by factorial of 5 plus 1 by factorial of 5 x to the power 5, okay, plus then 1 by factorial of 7 x to the power 7 or something like that. This is what he is saying. He is saying yes, 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 you are very much all right, because at the end when you try calculating the sin x, if x equal to pi by 4, then I believe it will be 1 by a square root of 2. If you keep setting x value and calculate the sin x, or calculate the sin x through that, this is called Taylor approximation. Now, or you calculate the sin x here through this formula, what we have taught, then it will come to same value. More or more degree you take, then more finer it will be closer to sin x. This is called Taylor approximation. So this is what proof we have brought in, but this is already done by Mr. Taylor. There is Maclaurin series and those things also. We will see that. Then mind-blowing, super blasting, that is the multivariate fxy equal to what? Now fx equal to y at x equal to 0 dy by dx x equal to 0 x plus d2y by dx square at x equal to 0 into x square by factorial of 2 plus d3y by dx cube at x equal to 0 y x to the power 3 by factorial of 3. This is what the approximation is. What about if it is multivariable? This is fx equal to. What about if it is multivariable? I have sin x cos y plus e to the power x into log of y. It is two variable. In that case, how we will proceed in the approximation? There is purely our invention. That complexity is not available. And I have seen the solution. Anyone would hit his head into the wall because there are so many approximations are there. Just imagine this, imagine this, and for the kind of this small value where it tends to 0, and then kind of a delta value, anyone will think that better leave it. So there our solution hits in multivariable, and when our solution hits in, then not it is only for x and y. It is for x, y, z. It is for n dimension. Anyone can calculate the generic form. Okay, so infinitesimally small approximation and those era is gone. That's why we are here. Okay, mathematics is not approximation. Mathematics is pure thing. Approximation will write approximation. Through approximation, we cannot calculate the concrete thing. Okay, this is what people do. Okay, so we will proceed in the innovative approach in calculus as far as Taylor and Maclaurin series is there, and then mind-blowing multivariable case that we will see. Please do support us. +91 is the India country code 9483160610. 9483160610. +91 is India country code.